Now we will communicate with the driver. In the previous video, we had developed the IO handling for neither buffered nor direct IO method of handling and the buffered IO method of handling. And in the previous video, we have developed the IO handling using direct IO. Now, using all these three IOs, we were able to send the user mode. We were able to handle the IRP in the driver level. But now we have to develop an application which sends the user mode message to the driver for communicating with the driver. So in the communicating with the driver section, driver communication, this is the code snippet that we will be creating, will be using to create the user mode application. Driver communication. User mode communication with the driver involves opening a handle to the device using its DOS device name. Example, in our case, Sixwings user will be the DOS device name that we will be using, as we have already established the connection between the DOS device name and NT device name in the driver. And we can also use directly NT device name as well, which is our device name Sixwings. If driver is compiled with the three different methods, IO methods, direct IO, buffered IO, and neither IO, for each method, the driver should handle IRPMJ write request corresponding to write file call and log the received data using dbg print. So write file call will be called from the user mode, and the driver will be receiving that call in the IRPMJ write request from the IO manager, and IRPMJ write request executes our IO handler for IRPMJ write request, which will be neither IO or buffered IO or direct IO. The same create file handle can be used with other file IO APIs, read file, direct IO control to interact with the driver. So to interact with other API also can be used with the driver. If you want to use other APIs at the user mode, read file or direct IO control or read some other API, that also we can use in the user mode to interact with the driver, because we have registered these functions in the driver as well. Now we'll be creating the user mode application. In the user mode application, we will be first opening the handle to the device, and then we will be writing the data to the device using the write file API. So let's develop a user mode application. We will open a new project, create a new project. We'll create a new project, and it will be a console C++ app. We will name it MSG 6 fins, and it will be presenting this directory, demo YouTube MSG 6 fins project we will create, which will be a messaging application which will send some request to the driver, and in future we also can receive some request using this application that we will be developing to communicate with the driver. msg6things.cpp is created. We will first include windows.h, then include t character.h, and then we will include stdio.h, and now we will write as usual int cdecl main void and inside it we will create a handle first to the file. So this will contain the handle to the device that we are opening. The word dw return, this will indicate that the API that we are using to open the handle to the device is successful or unsuccessful. H file equals to create file, we will be opening our device now. This will be the DOS device name representation that we are using, 6 strings USR. Next parameter will be okay, this is done. Next parameter will be DW desired access, which we will have the generic read and generic write access. Generic read and generic write access. Next parameter will be shared mode, which we will pass in 0, and next parameter will be security attribute, which will be null. Next parameter will be the open the DW creation disposition, which we will pass open existing. These parameters you will be studying in the notes what they are. Next parameter will be 0, flags or attribute. Next parameter will be null, the template. Now this create file API we have called, we will structure this API better read of parameters used in this way, and we can also do this open existing. Now if this is successful, if we get the handle of the device that we are trying to open, then we can write to the device using write file API. First parameter will be handle to file. Next will be the message hello from user mode. Next will be the size of the message hello from user mode. Next will be the return number of bytes that are written, and address, we will have address of DW return, we will be storing the number of bytes returned, and next last parameter will be overlapped that we will pass in null. So these we will also study what they are, these parameters for write file API, and in the end we will do this. And at the end of the day we will return the status for to indicate that the application is executed correctly. Return 0. Now this is done, we can now build the application and then read about these read file, write file, or the create file API. Let's go to the notes. Code example that we wrote. Open a handle to the device. The create file function is used to open a handle to the device. The create file function in Windows is used to open or create files, directories, physical device, disks, volumes, console input, output, and device objects. For device drivers, it is commonly used to establish a handle for communicating with a driver. So it will establish a handle to communicate with the driver. This API is used for that purpose for our driver development. So we open the handle using this API to the driver, but it is also used for creating files, directories, physical disks, volumes, console input output, and device objects. Especially, it is used for opening, in our case, opening the handle to the device driver that we are trying to communicate with. Now, what are these parameters that this API we have passed and used are LP file name, the name of the file or device to open. For device drivers, this is typically DOS device name, 6 things user, or an NT device name, 6 things. It is represented as this if we are passing the NT device name. This indicates that the application is accessing a device or driver, not a standard file. This indicates that the application is accessing a device or a driver, not a standard file. We are using this. This also indicates that the driver is being accessed, not the standard file being accessed. So here we passed what? Here we passed the 6 things users as the device that we are trying to get the handle of. Now DW desired access specifies the type of the access the application wants. Generic read access, generic write access. Both can be combined as generic read and generic write. So as the AR application wants both access to the device that it is trying to open, we write generic read and generic write as this way, as here we have written. Next parameter is DW shared mode, defines how object can be shared. 0 exclusive access, meaning no other process can access the device while the handle is open. So this means exclusive access. 0, the third parameter, means what will be the shared mode. Shared mode in our case will be the exclusive access. If we open the handle of the device that we are trying to communicate with, until we close the handle, we will not allow other process to open the handle to the same device. So here a message is there that we have to close the handle after we are done with our operation, which is sending the data to the device using write file API. We close the handle, then close handle API h file, which stores the handle of the driver device that we are trying to open. LP security attributes, the fourth parameter is, which we have passed is as open existing, which we have passed is as null. So LP security attribute, long pointer security attribute, pointer to a security attribute structure can be null for default settings. So for default settings of the security attribute, we have passed it as null, the fourth parameter. The fifth parameter is DW creation disposition, defines the action to take if the object exists or doesn't exist. Common values: open existing, opens existing device object, used for drivers. Open existing indicates that the application accepts the driver to already exists, device to already exists. So this flag indicates that we are assuming at the user mode level that the device is existing or not existing. Open existing flag indicates that the device we are assuming to already existing. So open existing indicates that device defines this particular parameter defines the action to take if the object exists or doesn't exist. Here we are assuming that the device already exists, which we are trying to get the handle of. DW flags and attributes. Flags and attributes for the object. For devices, this is typically 0 or file attribute normal. So we have passed in as 0 in our case. Files and attributes for the object. We have passed it as 0. Okay. Next parameter also the last parameter that we have passed it as null. Reserved for file creation, set null for device object. So for null, it is recommended that for device drivers, when communicating, when editing the handle of device drivers, we will pass it as null. It is reserved for file creation. This is a reserved parameter. So on successfully execution of this particular API create file, it returns a valid handle to the object. On failure, it returns invalid handle value and get last error can be used to retrieve error code. So at the end of the day, if this create file is successful, we will get the handle to the device that we are trying to open to communicate with the device. If it fails, it returns a invalid handle value, and the error code we can get using getLastError API, which we are using for now. In general, create file establishes a communication channel to the driver via a handle. The driver must have created a symbolic link 6 user that maps to its device object. So in the driver, we have already created a symbolic link 6 user, which maps to the device object and the previous videos to our device object, which will be 6 And in general, this API establishes a communication channel to the driver by a handle. So this API create file just is used for establishing a communication channel to the driver. So now the communication channel is established. Now we can communicate with the driver by writing the data to the device that we have obtained the handle of. The write file function sends the data hello from user mode to the driver. DW return captures the number of bytes actually written. So in the next, if we got the handle of the device, we call the write file API. So here write file API, what it is doing, it sends the data hello from the user mode to the driver. DW return captures the number of bytes actually written. So it returns and captures the number of bytes actually written. You stored in DW return in this variable. Now the write file function is used to send data to an object, file, pipe, or device identified by handle. So the write file function is used to send data to an object. It can be a file or a pipe or a device identified by the handle. So here in our case, the handle is a device. So we use write file function to send the data to the device, not to a file, not to a pipe, but to a device, which is 6 user. And we have already established the communication link, the symbolic link, the 6 user, and map it to device object. So now the API write file, what are its parameters? Handle to a file, handle to a device or a file. This handle is obtained by a create file API. So we first have to get the handle using create file API, then we can use that handle in our write file API. And that handle in our specific case would be a handle to a device which we opened. Now allowing pointer buffer, a pointer to the data to be written. For drivers, this is user mode data being sent to the driver. Example, hello from user mode. So in our case, this is the user mode data that is sent to the driver. In our case, it will be hello from user mode. This is the data to be written to a file or to a pipe or to a device. Here, in our case, it is hello from user mode, which is user mode data being sent from user mode to the driver. User mode application is our user mode application to the driver. N number of bytes to write specifies the size in bytes of the data to write. So here the third parameter specifies the size of bytes, which is size of the user mode buffer to write. Long pointer number of bytes to bytes written, a pointer to a variable that receives the number of bytes successfully written. So this variable will be receiving the number of bytes that are successfully written, the number of bytes that are successfully sent from the user mode application to the driver. Next parameter we have passed it as null, LP overlapped. allowing pointer overlapped, used for asynchronous overlapped IO. For synchronous IO, this should be null. So we can study about what are synchronous and asynchronous IO. Here we have passed it as null, which means we are assuming that it is synchronous IO that we are dealing with. We will not go in deep in the synchronous and asynchronous IO for now. We will move on and just assume that the we are dealing with the synchronous IO only. So we will pass it as null. Now return true on success, returns false on failure. Use get last error to obtain the error code. So this API actually returns true or false on success or failure. We can use the get last error API to get the last error code if this API fails, but we haven't used for now. We may use in upcoming videos or not, we will see. In general, write file sends data from user mode to driver. This results in the driver receiving IRPMJ write request. The driver processes the IRP and performs the desired action based on the written data. So write file sends the data from user mode to driver. This results in the driver receiving IRPMJ write request. So when the user mode data is sent from the user mode to the driver receives an IRPMJ write request from the IO manager, which the driver can process the IRP and performs the desired actions based on the data written. Here, the desired action will be printing the data which is coming from the user mode to the driver in the debug view that we have already done. How create file and write file work together? Create file creates a communication channel by opening a handle to the driver's device. Write file sends the data to the driver through the handle. This data is passed to the driver via an IRP with a major function of IRPMJ write. So create file creates a communication channel by opening a handle to the driver's device, and a write file sends data to the driver through the handle. Sends the data to the driver through the handle. This data is passed to the driver via IRP IO request packet with a major function IRPMJ write. User mode write file call. Kernel passes IRPMJ write to the driver. Driver processes the data and optionally sends the response back. Here we are not sending any response back in our case. And close the handle at the end of the day that we have forget to close the handle. Always close the handle of the device we have opened. So we closes the handle in the user mode. The application ensures that the handle is closed properly after communication is complete. So this is all about the theory and the code that we have written. So now the user mode application and the driver communication has been established. Now we can go ahead and try the driver and the user mode application and the service all together and see every write request being sent from the user mode to kernel mode and how the driver is handling every write request. So we will first use uh, do direct IO. So in the do direct IO, what will be happening is we will be converting the user mode virtual address to kernel mode virtual address and locking the user mode buffer and writing that data from the user mode to the driver in DBGB. So it is successful. It is also successful, and our service was also there. Let's see where the service is. Use 6 string service. This one was not. Go in here. It's here. And 6 string service is there. So we'll replace every binary freshly and compile the driver and replace the driver and binaries, user mode binaries. We will rebuild every solution, the user mode application and the driver. Now we will open the virtual machine. Let me change things so that it starts. Let's go with 4 virtual processors. And, 5 and 2. Let's see if it makes sense. Let's try again and give this 5 and 2 as well. Okay, let's try again and let's increase processors. Okay. Let's don't use this many. Okay. Decrease. Let 126. Let's try 126. 126. Let's try dynamic. Okay, the machine is up now. We will see. And binaries are compiled successfully, I think. Let's compile binaries. Heavy application. Okay, it got successfully compiled. It was also a success. And it was also a success. We will wait for the windows to be up. Terrible problem. Hmm. Just again close everything. Turn off the PC. Go to settings. And work now. Okay. The RAM is not 2, 4. Hmm. Let's try again. 56. It should work now. We can connect. Yeah, let's just copy our binaries. This one. The service, the user mode application, and the driver. Okay. Now we will replace the service. Is done. We will replace the user mode application. Get the driver, which we will currently have the do direct IO set. It will do the direct IO. Our driver will be presented drivers folder. We will copy the driver to the drivers folder. The system is kind of slow. Let's see. Drivers. We copy the driver and we will run the application and view that application logs in the driver logs in debug view. So we first start the service application, which starts the service. The driver is loaded. We get the driver entry. Now we will communicate with our driver using MSP6 Wings application. Communication is complete. Here what we get is dispatch direct IO code. Here we printed the user mode message and done dispatch cleanup code, request close code. The main important thing is we get that dispatch IO is executed on communicating with the driver, because we have set the driver to handle the write request in the direct IO. We printed the inside the direct IO printed hello from user mode. Now we will close the service and driver unloads. The same thing we will do with the remaining two ways of handling IOs in the driver, which is buffered and neither direct nor buffered. Build the solution. Okay, we build the solution and now we will replace our driver. This will be our driver. Copy and pasting. From here we copy and paste driver in drivers folder. Now we go back and execute the service application, which starts the service and loads the driver. The driver entry is called, and now the communication from the user mode to the driver will happen in buffered IO. Communication done. Whatever is called dispatch buffered IO called, and hello from user mode is printed in the driver as usual. Apart from that, we see that create is also called because we open the handle to the device, and clean up and close when we close the handle to the device. So that's why these are being called. As user mode is communicating when opening and closing the handle to the device. At the end of the day, we close the service and driver unload is called. The last thing that we will do is compile the driver in neither direct nor buffered way. So we compile the driver and it is successful. We copy it and paste it in desktop. And then on drivers, where we will be loading the driver. So here we will first start the service, the kernel mode service using this application, which loads the driver. We loaded the driver. Now we will do neither buffer nor direct IO. Communicate with the driver. The communication is done, and what happens? Dispatch write neither called, and the printed message from the user mode is printed in the debug view at the driver level. And apart from that, create, clean up and close is called when opening the handle and when closing the handle to the device. At the end of the day, we unload the driver by stopping the service. So this is the driver communication, writing the driver, writing the user mode application, writing a service which loads and unloads the driver.